we go. First of all, way back in the day, they did a temperature scale. All right, temperature. It's a hell of a word to spell. Okay, so temperature. The first basic temperature scale is what? Used here in America. Fahrenheit. Okay, trying to spell Fahrenheit. I'm not sure. I'm just going to go degrees out. Because I'm going to mess it up. It's like H-E-I-T. It's weird. Okay, so the range of values. What's the freezing point of water? 32. You know this because if you watch the weather tonight, you're going, is it below freezing or is it above freezing? Or is it right about freezing so that if we get snow, it sticks, right?
Yep.
Now, I'm asking you, please, no snow day off.
Yes.
We're already going into June. I don't want to go further into June. You like it. The rest of us not so much. All right, now, so what's the boiling point of water? It's weird.
I know
It's 212 degrees. Now, how did they come up with that? Because back in Fahrenheit's day, he figured out the lowest thing that he could find and called that 0. Okay? That was the lowest, the coldest temperature he could come up with. All right? Now, then they said, man, I'm not so good with this. So they came up with another temperature scale. You ever heard of the one we use in science? Celsius. Okay, and I can spell that one, I think. All right? I think it's that. It might be this. One of those. I'm not sure which. Okay, now, this is a little more logical. What's the what's the freezing point of water? 0. What's the boiling point of water? 100. That's easy, right? Now, what they actually do is they take thermometers and they put it in freezing water, they put a mark. They put it in boiling water, they put a mark. And then you divide up 100 marks between them. That's all they do to make a thermometer. The old school, glass thermometers. Does anybody actually have like a mercury thermometer at your house besides me?
Doesn't work.
Right? Doesn't work? Well, then it's a piece of glass.
Yeah.
All right, but they're really pretty accurate because the mercury expands and contracts pretty well with the temperature. All right?
Hey, yo. You see these dogs? They're at your front door. No, go. Bing bong. I'm doing
All right,
ASMR.
now. Okay, so here's the thing. You can go really, 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 really cold. True? You can go below 0, obviously. Can you go below 0 Celsius?
Yes.
Can we go below 0 Fahrenheit?
No.
Yes.
Oh, yes.
Okay, there was actually this one really cool. You just want to be loud in the video.
No, I'm doing ASMR.
Okay.
It's okay.
All right. So anyhow, I got to find this video. You ever seen the one where the guy takes boiling water out in he's up in Siberia or someplace? You know what I'm talking about? And he throws it in the air.
Oh.
All right, and it snows.
You see the one where I fell into it?
Okay, we're not
Snow.
going. Anyhow,
Snow.
just stop.
Okay.
All right. So anyhow, All right. So anyhow, no, that's it actually got so cold. I told you the one about freezing my hands to the metal. But it can be so cold that you can spit, you can expectorate, and it'll freeze before it hits the ground. That sounds like bullcrap, but if you figure you can throw boiling water in the air and it freezes in the air and turns into snow, a little bit of spit is not nearly that warm, obviously. Okay. Now here's the problem. If I make some gas, so here's the relevance. If I make some gas hotter, it gets bigger or smaller if it's like a balloon. What do you think? What happens to kindergartners if they get hotter? Are they moving faster or slower? They're moving faster. So if they're moving faster, they're going to hit the walls harder, right? Does that make sense?
Mm-hmm.
If they hit the walls harder, what's going to happen to the size of the balloon?
Get bigger.
It's going to get bigger.
And then full.
What's that?
And then it's full.
And it could pop if it gets hot enough. All right? Now, here's the trick. Are there temperatures below 0 Celsius? Sure there are, aren't there? All right? We want to be able to relate the size of the balloon to the temperature. But this scale is screwed up. there are temperatures way, way, way below zero. So there was this guy named Kelvin who said, okay, let's fix that. Let's make zero the absolute zero. And he doesn't even use a degree, he just uses the K for Kelvin. All right? And that temperature way down there is negative 273 degrees Celsius.
Why is that the absolute zero?
Okay, why is that the absolute zero? What they did, and I didn't make you watch this really long video, but what they did was they said, okay, we're going to take gases, and we're going to make them colder and colder and colder and colder, right? And the pressure changed according to the temperature, okay? So the pressure, if this here is temperature and this here is pressure, all right, as we made them colder and colder, the pressure dropped. And all the gases fell on this same line, okay? Now, this was as cold as they could get. So what they did was they said, okay, what's the coldest we can possibly get? All the way down to where there's no pressure, like no gas molecules at all. They're not moving, they all freeze. And they extrapolated, that's a fancy word for they extended the line. And they said the coldest it can possibly get is negative 273 degrees Celsius. That's where all molecule motion stops. There is no energy, okay? Now, Kelvin said, okay, I'm not going to be like this whole Fahrenheit Celsius thing, man. How do you convert from Fahrenheit to Celsius? It's like 9/5 plus 32 or minus 32 plus your shoe size and your mother's age or something. I don't know how that
It's good.
All right? But he said, we're going to keep this simple. For every 1 degree I go here, it's 1 degree here. So if this is negative 272 degrees Celsius, this is 1 Kelvin. So if this difference is 273, what's 0 in Kelvin? 273 Kelvin. What's 100 in Kelvin? 373. All right? So to do any calculations with gases, we have to use Kelvin. Because think about this. What if I'm inside this room, it's about 20 degrees in here right now, and I go outside, and it's about 1 degree. Does the balloon get 20 times smaller? You ever done that? You take a balloon, right? Take a balloon and go outside. Does it shrink? A little bit maybe? If you get them cold enough, do they get smaller? Things, when they get cold, they get smaller. They shrink up, yes? Yeah. Okay. Same thing with gases. If they get colder, they shrink up. But if you go from the room here to outside, it doesn't shrink down a whole lot, does it? Okay. So I want you to start to think about that. Just planting the seeds. We'll talk more about that tomorrow. Can you kill that?
Do I just press the red button?
Just push the red button.